In this video, we're going to explore the relationship between pointers and arrays. This extends to the idea of strings as well, because remember, all strings are really just arrays. We're going to look at how we can move a pointer around in relation to an array, and we're going to use something called pointer arithmetic as well, playing around with this a little bit. So let's take a look at this code here. We'll talk about how it works and draw out some memory. We have a couple function prototypes. We have a prototype for something called array printer. It takes as input an integer array and the size of that array. It also returns void. And then we have this other this other prototype here called find smallest. It also takes an integer array and a size of an array, but it actually returns a pointer to an integer as its result. In our main, we have an array defined. It's an array of 4 elements, 5, 2, 7, and 4. And then I print the array calling the array print function. We have a pointer p. When we assign that p equal to the result of the find smallest on AR, and then we print the smallest, and we'll get into that print statement in a second. It's got a new format specifier, a %p, something we haven't seen before. Let's take a look at these functions. Array printer. It just is a for loop that walks through the array, but it does something with the pointer here, and we're going to talk about that. And then our find smallest, we're going to again walk through the array. We have an if statement in here with a test to see if we've found the correct element, and we are going to explore that in a minute as well. So before we actually look into these functions, let's take a look at the relationship between arrays and pointers. I'm going to draw my typical rectangle for an array with different cells. And we're going to call this array AR. And the name of the array, the name of any array, is a pointer to the first element of the array. The only difference between a pointer and the name of an array is that the name of an array always points to the same memory location, and a pointer can change the value stored inside its address, where it points at the memory location. So the pointer can change the memory location that it points to, but an array name always points to the same memory location no matter what. So an array is immutable in its location, but a pointer is not. We can create another variable here, like p, and it can be a pointer. And we can have p point to any element in the array, just like we can have p point to any memory location in our program. Arrays are always guaranteed to be right next to each other in memory. So the first element of an array is immediately next to the second element. It's immediately next to the third element. There's no spaces between them. What this means is if p points to the first element of the array, we can actually say p equals p plus 1. And what that means is move p 1 cell up the array. And so now p, instead of pointing to the first element, now would point to the second element. When we refer to the array, because an array is just like a pointer, when we say something like AR with square brackets and a 1 in it, what we are really saying is AR is a pointer. So we're saying AR plus 1, whatever the pointer memory value of AR is, which always points to the 0th element, plus 1 more element to get me to the 1th element. And then you want the dereference, the star of all of that. So star parentheses AR plus 1. That is the exact same thing as saying AR square brackets 1. These mean the same thing, which also means that if P is pointing to the first location of the array, then P plus 1 dereferenced is the same as saying R plus 1 dereferenced. So these are really similar concepts, the pointer and the array. Really, the only thing that's different between them is the ability to move the pointer and not the array. You can't, in this AR plus 1 dereferenced, what you can't say is AR equals AR plus 1, but you can say that for a pointer, but you can't say that for the name of an array. So let's take a look at these. So we have this array, and we're going to go to array printer. So let's take a look at array printer. All right, array printer, we've been given an array. That means we have a reference to some array somewhere. I'm going to draw my rectangular array representation. The next thing I have is a pointer P, and the line beneath that says P equals AR. That means if AR is represents the first element of the array, then we want P to be assigned to the first element of the array. So point to the first element of the array. We could also say, it is exactly the same thing to say P equals the ampersand of ARR bracket 0. So the address of the first element, those two things mean the exact same thing. So P equals ARR is the same as saying P equals ampersand ARR bracket 0 bracket. So the address of the first location. So we have this for loop. For I is less than the size, I plus plus. We're going to say printf, print %d and %p. %d we know is an integer. %p means the address of a pointer. So print the address of a pointer. So for each element, we're going to print the star p. That would be the value that P points to. And then we're going to print the address of that same location. And then P plus plus, move P so it points to the next element, print the value and the address, and then move P until it prints to the next element, and keep doing that for the whole array. When we want to reference the address of P, the pointer, we just use P. When we want to reference the value stored at that address, we use star P. We can move that pointer around by adding or subtracting to it. So P plus plus advances it down the array. You have to be a little careful here. It is totally legal to just keep going after the end of your array, as long as that memory is memory that is part of your function. This can cause some errors if you don't know what's passed there. Let's take a look at the find smallest. So the goal of this, just to get ourselves started, if you have an array full of values, I'm going to draw my typical array. What I want to do is I want to find the smallest value in this array. Once I've found it, I want to make a pointer to that array, and I want to return that pointer out of the function. So we have this array, and we have this lowest pointer that we've created as the first line of code, and then the second is we point it to the first element of the array. For each element in the array, the if statement here says if star lowest underscore pointer is greater than ARR bracket I. If the value, that's how you got to read that star, if the value of lowest pointer is greater than the current element of the array, then lowest pointer equals the address of that element of the array. I could also say ARR plus I, those mean the same thing. find that location and then store a pointer there. Finally, we're going to return that pointer. This means wherever we return this value to, they will have direct access to modify that element. There's direct access to modify that element. Now, if we go look at main here, create an array. We use that print array to print it. I create a pointer. I set that pointer to the value returned by find smallest. I print the lowest value is %d and its location is p. One more thing let's add to this. Let's change the value of p. So I'm going to set p, which should come back as 2. I'm going to set the value of p, so star p. I'm going to set it equal to -90. Now we're going to set it to 99. And then I will print the array again using the array printer function. Now let's give this a run. I'm going to clang file. And I'm going to run it. And the first thing we do is we go through and we print the array, and it's 5, and then it has its memory location here, and then 2, and then its memory location here. The only thing I want you to notice about these memory locations, the actual numbers are not really important, but notice that each one of them is 4 units away from each other. This one ends with 3-0, the next one ends with 3-4, the next one ends with 3-8, and then 3C. Each of those are 4 bytes away from each other. And that's because an integer is 4 bytes, and this is an array of integers. So each integer address needs to be 4 bytes away from the previous one. You'll notice that after I find the lowest, I print out the lowest value is 2 at this location. And then finally, I reprint that array after changing that value. And because I had that reference, I could directly change the value inside the array. The lowest has been changed to 99. So this is the relationship between arrays and pointers. Again, they're really the same thing, except that arrays can't move, pointers can. And we can move pointers by adding or subtracting to them and move or down an array. This is actually how a bunch of string functions work, but we'll look at those in a separate video.